Welcome to this lecture number 23 on distribution systems. So far we have been talking on generation and transmission, and distribution system has been getting a very raw deal. Even in books you will hardly find a chapter or so, but let me tell you, there is a bias against it, and it is definitely not of secondary importance. It is as important as generation and transmission, because it is a distribution that reaches out to consumers and customers, industries, and so it should not be neglected. Of course, it differs from transmission systems in several ways. Number of branches and sources is much higher in distribution networks. General structure or topology is much different. Step down 60 to 11 kV on load transformer at bulk supply point, feeding a number of cables of different lengths, a series of step down 3-phase transformers are required. For example, 11 kV to 415 volts in India, and in US it is 4.16 kV to 240 volts. Please remember, they have 120 volt system, we have 240 volt system. Now, it is spaced along the route from where consumers are supplied through 3-phase 4-wire networks, giving 230 volt in India or 120 volt in US. That is what is finally required in domestic supply. Now, while designing a distribution system, what are the things that one has to keep in mind? What are the service conditions? Electrical design, mechanical design, various costs. Whatever you may do, the cost factor you cannot ignore. Whether you purchase anything, whether you go anywhere, the cost is such an important factor. Even that is very important while designing a distribution system. What is service conditions? Mainly the load study is carried out. It is not quite load flow study, but what sort of loads are there which you want to supply the power. Is it agriculture load? It is domestic load? Is it what you call industrial load? Or is it a advertising load, neon lights, hoardings, or is it a monuments, or is it a statues where you want to put light, or is it a airport lighting scheme, which is entirely different. So, type of load to be served you have to study thoroughly in distribution system. That much detailed study is not required in transmission system. There you can lump them. Density of consumer is very important. How many consumers are there at a given point, so that the feeder design will depend on that. The number of transformers will depend on that. How much transformer will be working for how much time. All these things are required while designing the distribution system, which we never bothered while talking about transmission system. Main loads are residential, domestic. A city like Delhi, you have 1 crore population. You can well imagine the residential load itself, especially when everyone is having all sorts of gadgets at home. You have vacuum cleaner, hair dryer, you have iron, washing machine, AC, coolers, stoves, ovens, microwaves, and everything, even shaver, everything now you want to do needs the input of electric energy. Commercial load, I talked about advertisements, shops, malls, plazas, all this need electric power. Industrial, small scale industries, large scale industries, medium scale industries. Just aate ki chakki, he has only just one motor, but that is a load, that is a small scale industry. Municipal traction, there are towns and cities in the world, though very few in number left now, where the tram is still working. In India, Calcutta is the only city where you have the tram even today. Melbourne in Australia, San Francisco in USA and in Europe, there are certain cities where still the municipal traction needs electric power. Now I am going to show you a typical distribution system showing the main parts. This is a bulk power source. Power is coming from the transmission system. Now this is a transmission subsystem, that is transmission substation. Sub-transmissions, the whole thing is known as sub-transmission system. Transmission system we are not going to study now, we have been studying in earlier lectures. Let us say it is 66 kV. Then this is a distribution transformer. Then there is a primary feeder. This substation is called the distribution substation. The voltage is already lowered from 66 to let us say 11 kV. Then we have 415 volts. Now this is 66 to 11 and this goes 11 kV. This is secondaries, these are consumers. Now these consumers can be domestic, can be commercial, can be small scale industries. If it is a big industry, then 11 kV directly is given to them. So I think this is a self-explanatory diagram, everything is quite crystal clear, and this is what a normal distribution system will look like. The distribution system may be subdivided: primary distribution, distribution transformers. You have seen poles in cities where the transformers are placed. Secondary distribution and consumer service connections. Finally, the power comes to your place. Proper voltage is very important. In any distribution system, the voltage, if it is not proper, your system won't work, your fridge won't work, or you will have to put voltage stabilizer, which you normally do in India. Everywhere you have to have a voltage stabilizer, you have to have a UPS system. Location is important, where you are going to locate. You just can't erect a pole anywhere you like. I mean, the transformer you can't put anywhere you like, and the entry point to your house or your premises has to be really external to the premises. The fellow can't enter your house and then read reading, because billing has got to be done, metering has to be done. So that is done, it has to be outside, it can't be indoor, it has to be outdoor. By outdoor I do not mean away from your house some 50 kilometers or something, no, it may be somewhere where it is safe, it is protected, and yet it is outside, so that the guy can come from electric company and note down whatever he wants to note down. Then protection is equally important. Fuses, MCBs, and they must be chosen for various components of the distribution system. As is protection of transmission system is important, as is the protection of generation system is important, So, equally if not more, the distribution system protection is important. For example, in transformer you have overfluxing relays. Now, what are the different types of distribution systems? Electric power used to be distributed in olden days by radial DC systems. DC used to be very popular earlier. Even Calcutta, even now they have a DC power. If you go any house in Calcutta, you will find they have both AC, DC. So, radial DC systems. Electric power now in 21st century, new millennium, is practically universally distributed by AC systems, barring few exceptions, as I just talked about Calcutta. Now, distribution system can be divided into two parts, categorized into two parts: primary distribution system and secondary distribution system. Now, distribution systems can be classified as follows: the radial system and lateral system, the normal system. Now, the radial system serves the light and medium density load areas, especially the lighting. The house, mainly house, you have lighting. Feeders are not tapped in between the sub-transmission subsystem and distribution subsystem, while distributors are tapped throughout at several points to serve the consumers. This has to be properly designed, where you want tappings, which route you want to follow, which will be optimal, because each meter of cable costs, it is not free. The other system is, besides radial, parallel or loop system. Now, the circuit returns to the same point, so that there is in effect one feeding point only, loop. It completes on itself. As the alternative path is available in case of fault, this system is more reliable than radial. Radial system, if there is a fault, you have to just wait for the removal of the fault, or you have to resort to your inverter or alternative or non-conventional energy sources, if you have any in that building. Like we have a photovoltaic, we have on our energy building, the photovoltaic system used to be there. We used to supply the committee room. So, we used to get power all the time before this standby power was placed in place. So, this loop system is decidedly, definitely more reliable than your radial system. Network or grid system of distribution. This is a third Before we go this, let me show the figure of parallel first. We will come back to this. This is the parallel or loop distribution system. Here is a bulk power source bus, bulk. Then these are the loop circuits, parallel circuits, sub-transmission circuit, transformers, ring loop, again a transformer, and these are consumers. If there is a fault here, you can even get power from here. That is what I mean when I say it is more reliable. Come back to network or grid system. Preferred for large distribution areas, large loads, whole of Noida, whole of greater Noida. Now this has become a very dense the area. Lot of Ghaziabad, lot of industries are there. Gurgaon, Faridabad. Preferred for large distribution areas, for large loads, greater reliability with advantages of grid system. It is practically a micro grid, they call it. It is not a normal grid which we talk, 11 bus, 21 bus, that is the whole country is around 1000 bus. But this is a micro grid, and this is a very strong grid, because in that in New York, city of New York, you can't afford to lose power there. It will be chaotic if power goes, as indeed it went some time back, and there was for 18 hours no power. So this system has got to be more reliable, more sturdy. Let us show the figure. This looks like a transmission grid network. This is a sub-transmission substation. These are various substations everywhere, transformers, and these are loads, and these are bigger loads. These are not smaller loads. As I gave you an example, the BHEL factory, it is a bulk, consumer, Haridwar for example. And that factory works, it's a Maruti factory, 24 hours. So you have to guarantee them supply for 24 hours, so that the supply line is continued and you continue to get production. So this is a network or grid form of distribution. So if a question comes, draw or talk about network or grid form of distribution, you talk this and need to write those lines. Naturally, this system gives better voltage regulation as feeder length is small as compared to the radial distribution. So even in distribution, all those factors, performance indices are there. Efficiency, for example. I don't know whether you have forgotten, in machines course you might have studied all day efficiency. So we don't have any such term in transmission system, but here which is an indicator how well the distribution system is operating, all day efficiency. And you have to compute that, you have to calculate that. Then you have to see how much load is there for how many hours, and then you have to find out those efficiencies and power supplied and what is the quality of that power. What consumer feels or sees or comes across is the power that you supply to him, not power in Singrauli, not power in a big substation called Punky. They feel what power comes to your house, whether there is a flicker, whether bulb 60 watt bulb is behaving like 40 watt bulb or is behaving like 100 watt bulb. So quality, power quality is very important in a distribution system, because your impression of your company is judged, is formed on the basis of quality of power that you get in your house. You are not bothered what power is coming in Singrauli, being generated in Singrauli. That may be 50 hertz, that may be absolute 400 kV. I am not bothered about that. I am The consumer forms impression based on the quality of power that you get in your premises. The earlier one, the simple form of radial, I did not show you the figure. Here is a figure. See how simple is this. This is from beginning of civilization, when the electricity started about 100 and now 15 or 20 years back, 1886. So, isolated systems they were, there is a load, there is a generator. So, there is hardly used to be any distribution or transmission. The thing which we are now coming back, and circle is full, and that is called dispersed power system, as I have been mentioning to you throughout the course of this course. Wherever your load is, have a small generator, start generating, no transmission, hardly any distribution, just it straight goes to the load, and whatever quality you want you can maintain. It is your generator, it is your system, you are not paying anything, you have already paid whatever you wanted to pay, you only maintain the system, and fuel cost of course. And if it happens to be a wind and solar, then fuel is also free, you do not have to pay any fuel cost for wind or solar or anything of that sort. So, this is that simple form of radial distribution system, which is again coming back and becoming important thanks to the dispersed power systems and distributed power systems. If you want to learn more about these two topics, which are very important, please read a book by 1999 published IEE Lee, the author. I have a book, you can come and have a look at it if you want to do any project in that, because the future belongs to dispersed system and distributed systems, and of course non-conventional systems. So, is a substation bus, is a transmission substation, primary feeder either 33 kV or 11 kV, the transformer, load, distribution transformer and load, which is 415 to 240 volts, 3 phase 4 wired systems. So, this is really coming back in full force, though it is less reliable as we said already, but then you can always build in reliability, see that there are no faults, and even if faults take place, they get removed quick time. Now, we come to the last topic in distribution systems. What is this last topic? Section and size of feeders. What do these feeders do? Why they are so important in distribution systems? Because it is they who carry current from one substation to another, or to a transformer, or to a feeding point, and are not tapped in between. They are loaded at substations only. Now, let me tell you, when we used to study the distribution system, used to be 3 chapters, 4 chapters. See the Cotton's book. The only book, good book available in distribution, which carries from first page to last page topics on distribution, is by Gonen. Distribution Power Systems by Gonen, G-O-N-E-N, McGraw-Hill book. Otherwise, there are only 1 chapter in each book. How do you do voltage control at feeding points? Same methods. You had to have those capacitors, your inductors, or SVS, or facts. There is a big family of facts now. There are books available on facts. The recent book is by Mathur and Verma, very good book on facts devices. Both Indians, both settled in Canada. Now, size of the cable conductors is chosen by application of Kelvin's law. I am sure all of you must have learnt Kelvin's law in your some course or other. Still valid. What does it give? What does this law state? It talks about the most economical size of the conductor. It gives you more. That is what is required. Money. It saves you money. What should be the size? That is given by computing an objective function which comprises sum of the annual charge on the capital investment and the annual charge due to loss of energy. These are the only two charges that a company has to pay. What is the capital investment? How much money a particular person is shelling out to build that system? That is the capital investment. And the annual charge due to loss of energy. Other charges you get back. What you do not get back is loss of energy. And this is a lot in India. You can't ignore it, as if Kelvin sensed it that something is going to go wrong in India. So, he pronounced this law, otherwise there was no necessity to include this term. And distribution system, the losses are pretty high, 60%, maybe due to bad design. It is not that always theft is there, bad maintenance. Why do you get a low this kilometer, in your car, old car? Because it is inefficient inherently, not that somebody is taking the petrol out, if it is your personal car. Now, this should be minimum, the two sums, summation of two terms. That is what Kelvin law said. What is the annual charge on the cost of cable and distribution? P1 plus P2A. What is A? A is the cross sectional area of conductor. It symbolizes the cost. What is P1? The constant part of the annual charge. It includes salary, it includes depreciation, it includes sinking fund, it includes any rent that you pay for the premises you are occupying, or taxes, municipal taxes, any other expenses which are constant you have to pay. Your own cost for the power you are consuming, do not think that is free, you have to put cost there also. For example, if you have a medical shop and if you are consuming yourself some medicines, do not think it is free, you already paid for it and you have to include it in expenses. So will be any shop, kirana shop or your restaurant. If you yourself start eating those samosas, do not think it is free. And what is P2? Part of the annual charge dependent on A. What is the loss in kilowatt hour during the year? I squared R into 8760. 8760 is the number of hours that you can have in a year. I is the line current in 3-phase line. So, cost of energy loss per year is proportional to 1 by A, rest of the things are constant, because R depends on rho L by A. Rho is fixed once you fix the material, L is fixed once you fix the feeder or transmission line or distribution line. So, what is a variable is A, that is all you are allowed to vary, rest things are given to you, that you have to transmit power from this place to this place, you have to distribute power from this place to this place. So, length is fixed. If you want to change the sign of proportionality to equality, you have to multiply it by a constant. So, P3 by A. If I add all these things now, so I get in Kelvin's law minimization of P1 plus P2 into A plus P3 by A. Now, what is a optimization problem? When does this optimization started? The optimization was not known till Second World War. There was no optimization. Perhaps there was no need. Choice. Optimization only comes in when there are choices. Otherwise, where is optimization? If only one train is going to your place, there is no choice. So, you can't talk of optimization in the sense which will take less time, which is a passenger train, which is the express train, which is Rajdhani, which will give you food. There is no choice. So, there is no optimization. If you have got admission only in energy, that there is no optimization. If you get admission in IDDC, you get in electrical department, you get in care, you get in energy, then you can choose which one. Or if you get admission in IIT Bombay, IIT Roorkee, IIT Delhi, then you can choose. But if you have got only in IIT Delhi, there is no choice. So, optimization only works when there are choices. Now, here we have a choice. We can choose a particular feeder, we can have a cross section. So, I was talking about this optimization started in Second World War. Why? Because when Hitler forced the war on the world in 1939, practically the whole world was being ruled by England. There was no sunset. Now, there is only sunset. Sun never rises anywhere. So, Churchill called a meeting of all his engineers and scientists in a big room like this, or much bigger than this. Asked them, ladies and gentlemen, as usual that time also ladies were fewer in number, same trend is still continuing. Please stop working. They were so happy, oh stop working. But they were worried whether he is sending us to the front to fight the war. The next sentence he spoke was, start working in military operations research, MOR. I do not want my people to die in the war unnecessarily. I do not want to spend money unnecessarily, though I am the biggest empire in the world, but still I do not want to this hardly earned money to spend like this. So, give me a strategy, how many fronts I should open. People say Hitler would have won if he has not opened too many fronts, which he could not manage. So, he gave them instructions and he used to keep real time monitoring and control of the war positions without computers. The first computer, as I said, was invented or was created in 1948 in Manchester, UMIST, where I told you that I went there, and that computer was called baby computer, and it occupied this space and still is there and is working. So, without computer they were supposed to do real time monitoring and control, and the engineers, the scientists started working on developing an optimization technique. It so happened the war was over, the technique was still not found out, and the first technique was found out was linear programming by a guy called Danzig in 1945 when the war was over, thanks to the atom bombs. So, atom bombs won't have been there would be no war, would have continued. So, this linear programming was what? In any optimization process you had to have three things: objective function, how do you start, where do you end, and what path you follow, step size. Suppose you want to start from AIIMS and you want to come to IIT, at what step you should ask question, where is IIT? Suppose you ask in Mehrauli, he will say you already left IIT behind. So, you may ask in Green Park, you may ask in Aurobindo, and then of course, close to IIT, and you will find IIT. So, what should be step size? When do you stop stopping criterion, starting criterion. How do you start? Where do you start? With what value do you start? So, linear programming means objective function was linear, the constraints were also linear, and the answer was there. And there was guaranteed that answer will be there. You have to only compute on corners. That was a simplex method. This method which we are following here is a age old method of calculus, that first derivative should be 0, and that will give you optima. And if you have to worry whether it is a minima or maxima, examine second derivative. If it is minus, maxima; if it is plus, it is minima. So, if you differentiate this equation with respect to A, we get the economic conductor as P2A is equal to P3 by. This is the condition you obtain. This you can do at home. It is a very simple calculation, and see you get this answer. However, Kelvin's law has several limitations, and hence it is no longer used. This is just for your education that I have talked about it, and it may not give you the global optima, it may give you local optima. If a certain load is given and the length of the line is given, the most economical voltage can also be found out. At what voltage you should distribute power, that also you can find out. In India, the standard voltages used for primary distribution are 3.3, all are kV, right? 6.6, 11 kV, 3 phase, 3 wire system. The most economical distance between substations, and therefore number of substations in the system, is a function of distribution voltage used, and it is another optimization problem. In IIT, I do not know how many of you know how many substations are there. Did you ever bother to find out? One is near sick bay, that is hospital, one is near block 4, one is, yeah. So, there are so many substations. Now, you can study why they are there, how their sizes have been selected, what is the total demand of IIT Delhi, how the power is supplied. This is again an optimization problem which can be taken as an MTech thesis. The primary feeders may have a rating between 500 kVA to 2500 kVA. This is a range in which the primary feeders can be there. The distribution system is designed for a total voltage drop of 8 to 10%, not more than that. This is a voltage regulation I am talking. The neutral of the distribution system is grounded properly, thoroughly, so that there is a protection against lightning, not lightning, but lightning. India, design of rural distribution system is very important. Why? Mahatma Gandhi used to say India lives in villages. The 80% population still live in rural environment, and all of them need power, all of them do irrigation, all of them need power for their pumps. A distribution system has to serve consumers by long lines with low load density. Why? They are all across India, the villages are scattered, and you have to carry those distribution lines sometimes deep into the villages, and density is very low. Certain villages have only 100, only 1000. There is one, the Falklands near Argentina, where only 1800 people are living, for which the war was fought between England and Argentina in 1982. I do not know whether you are aware of it. Only 1800 persons were living in that place. Hence, it should be least expensive. durable and reliable. REC has been, not Regional Engineering College, Rural Electrification Corporation has been set up to finance this rural electrification program long back by Government of India by providing suitable loans, soft loans with low interest rates. As it is now, we are passing through low interest rate regime, but these interest rates are still lower, almost interest free for the projects. Designing the industrial distribution system needs special care as the load groups and demands are concentrated. High utilization means high losses over a long period of time. So, these are very important factors for designing plants. What should be the plant rating? As I told you, the reference book is Gonan, which is the best book. The title is Electrical Power Distribution System Engineering, McGraw-Hill, New York, 1986. There is one Indian book as well by Pabla. It is in 4th edition, and that is a wonderful book written by a practicing engineer. Not many practicing engineers write books, and you can have a look at that book also. So, this is what is distribution system all about. It is very important, as transmission and generation system. We need to take power to all villages. We have not yet electrified or energized all the villages in India. How many villages are there in India? 7 lakhs. Now, out of 7 lakhs, 85% villages have been electrified, and some of them, they say in a lighter vein that only lines are passing through them, but there is no power. Our challenge is to take power to them, take power to every Indian wherever he or she is, and then only we can say that really. Similarly, as Prime Minister's that road plan to take roads to all the villages, to interconnect the India through proper roads, well built roads. And if roads are not possible, then IIT Roorkee is working on a project of cheaper ropeways, so that you can go in hilly areas from one place to another, where perhaps roads cannot be built or it will be too costly. And that is why you find there is no rail link in states like Jammu and Kashmir. Still, you can only go up to Jammu and maybe Udhampur, not up to Srinagar anyway. So, ladies and gentlemen, with this we finish our distribution systems. Now, the next topic will be AGC, automatic generation control, which is very important, and that is the first topic and the only topic which caters for frequency of the system. We have been talking about voltages, we have been talking about power factors, but we have hardly talked about how to keep frequency constant within plus minus 0.5 hertz.